move to the last speaker, which is the CTO of SCIL, Marc Verschuuren, who's going to tell us about the substrate-conformed imprint lithography for micro-LEDs. You have the microphone?
Yes, thank you very much, and welcome everybody. Yes, my name is Marc Verschuuren. I'm the CTO of SCIL nano-imprint solutions. I would like to tell you about how nano-structured wafers or devices can help micro-LEDs. SCIL, yeah, it stands for substrate conformal, and I'll explain to you why that is of relevance for the micro-LED applications. We're a spin-out from Philips. We're located here at the high-tech campus, and we do the hardware tooling to do lithography, nano-imprint, materials, and customer-specific processes. We have a booth just around the corner when you exit, so talk to us afterwards. So there are many challenges for the micro-LEDs, and how could nano and micro patterns help there? So we already heard a lot of talks, and thank you for introducing the red problem and the green problem on efficiency. We'd like to go to a full nitride system, and using nano-templated growth could make this possible. Then you have, once you generate the photons, you need to extract the photons and actually send them into the right direction so you get usable light. Standard in LEDs, micro PSS is used, but actually you see that this cone is about 3 micron, so that's about, you get 1 or 1.5 cones if your LEDs get smaller. So you would like to work on photonic crystals. I'll show results from that. And then after you get the light from your LED, typically you need another optical component, a lens, to really shape the emission for the specific application. And therefore you would like to use a flat lens because it's more compact, it's inorganic, so it doesn't degrade, and it's actually easier to produce and more compact. So if you talk about patterning methods, there are a number of flavors. If you talk about nano patterns, there are less flavors. One is electron beam lithography. It's a very nice technology, very high resolution, high pattern fidelity. The problem is it's really slow. Think about maybe a few hours per square centimeter. So it's not for production, but it's really good for mastering. For nano imprint, you need one original master. I'll explain later. So we use E-beam and also optical lithography. Optical lithography, ASML tools, they have high resolution, but if you would like to go for these deep or sub-micron patterns, you have to go for really expensive tools. Think 60 million, 80 million, just CapEx investment, and then you still have to start. So it's pretty tricky to actually get access to these tools and put in substrates that are bowed, have particles, so your resist layer is not everywhere the same. Actually, it doesn't work with these tools. It needs to be very smooth, very flat, and very clean. Now at SCIL, we developed a nano-imprint method, and I'll explain you how it works. We actually get a much higher resolution than deep UV. We get the E-beam resolution. We can also do functional materials, so we directly pattern an optically functional material that works as a lens. The only thing is, compared to deep UV and E-beam, we don't have an overlay alignment that's in a nanometer range. It's in about half a micron range, which is still best in class for wafer-scale replication of any nil method in the world. Nano-imprint starts with a stamp. So the information is encoded in height instead of using optical lithography in light. As I said, with E-beam or optical lithography and multiple litho and etch steps, we make one times a master, an original pattern. So that's relatively expensive, but you only have to do it once. Then we build our stamp, a composite stamp with a special rubber that allows us to get nanometer structures. And then we glue this rubber with a soft rubber to a thin glass backplate. We have a stamp outside that shows it. Now the glass gives us rigidity in plane, so this is needed for overlay alignment.